Hey y'all, it's Julie the nursing tutor, and you the real Florence Nightingale. I got some dosage calculations that a student sent me. This is going to be part 1, okay? You ready? Here we go. Okay, so the order is for ceftriaxone 1 gram IM once daily. The medication is available in vials of 1 gram powder to be reconstituted with 2.1 milliliters of lidocaine to achieve a final concentration of 350 milligrams per milliliter. Okay, so we know what he wants is for them to get 1 gram. 1 gram. You know, kilograms, grams, milligrams, and micrograms. We got to convert it because what we have in our hand is in milligrams. And I'm going to get rid of the decimal. I'm not going to convert that to grams because a decimal will kill somebody. But if we're going from grams to milligrams, you got to move it to the right. And you have to remember that we're moving it 3 places. I just posted a video before this one about the reason why we move it 3 places. So 1 gram, the decimal's understood to be at the back of the whole number. I'm going to grab it and go 1, 2, 3. If they had wanted me to go grams to micrograms, let me show you. Grams to micrograms, I would go 1, 2, 3. I'm at milligrams. 1, 2, 3. Now I'm at micrograms. You see that? And then you add all them zeros. A lot of times they'll just have a light bulb in the middle of their head shining. But grams to milligrams, 1 gram is 1,000 milligrams. Okay? So that's the dose ordered. Now, all this about the medication available is in a powder, 1 gram, to be reconstituted with 2.1 milliliters. You do not use any of that to work this problem. You're looking for the concentration after you do all this stuff. You're looking for the per. You see that per right there? This is what you have to use to calculate this problem. The other is a distractor. So don't let it distract you, okay? 100 milligrams is what he wants. What I have that has the same last name, because they got to have the same last name to go in this fraction, is 350 milligrams. 350. How's that come per 1 ml? And look, this fraction, you see how I put their last name? So that Ethel won't have no question in her mind what I'm talking about. And this fraction says this divided by that. And then we'll multiply it times whatever's there. So look, get your calculator, pause it. I've had students tell me, I just watched it, but then when I did it, it made me better. So make yourself better. Here we go. 1,000 divided by 350 equals. And if we're multiplying that times 1 would be still 1. So we're going to have to give, she don't say to round. And so look, if she hadn't said nothing in the lecture about how she wants you to round, this is going to be an IM injection. So I'm going to leave it at 1 decimal place after the decimal. Because you see that 5 is going to make that, oh, dookie fart. That 5 is going to make that 8 and 9. And I quit cussing one cuss word at a time, and I'm on the S word, and I say dookie fart, and it works. So it would be 2.85, and then that would be 2.9. What? Whatever you tacked on right there. You're going to grab it and put it down here. 2.9 milliliters. You can draw up 2.9 milliliters in a 3cc syringe. And so, there you go. Okay, let's do another one. Okay. The doctor orders an increase in a dopamine infusion from 5 micrograms per kilogram per minute to 10 micrograms per kilogram per minute for a patient weighing 70 kilograms. The dopamine solution is prepared with 400 milligrams in 250 milliliters. Calculate the new total dosage desired per minute, and then calculate how many milliliters an hour. Okay, so grab your beverage and get a little sip, because I know you just threw up in your mouth for a little bit. But it's going to be okay. Thankfully, they gave us the 70 kilograms. So it was 5, now he wants 10. This says 10 micrograms for every kilogram. We got 70 of them per minute. And so we have to multiply 70 kilograms times 10 micrograms. Okay? Hang in here with me. You're going to be fine. 70 times 10 equals 700. 700 micrograms. And what is that? It's per minute. Per minute. Okay. And then calculate the new total dosage required per minute. This is going to be your answer. 700 micrograms per minute. Okay, and then we have to figure the milliliters per hour. This is per minute, so I can multiply this times 60 to see how many micrograms they're going to get in an hour. So 700 times 60 equals 42,000. 42,000 micrograms per hour. I would encourage you to write this out like this so you know where you're at in the problem. So this is how much this is the dose ordered. But you see what we have in our hand is milligrams. This is micrograms, so we've got to convert it. And look, I wait till I get a big O number like that. kg, g, mg, mcg. So if we're going from micrograms to milligrams, we got to move our decimal that away. And so I'm going to grab it. It's understood to be at the back of this whole number. I'm going to grab it and go 1, 2, 3, put it. And so the new dose order would be 42 milligrams per hour. So this is what he wants. What I have in my hand that is milligrams, because they got to have the same last name to go in this problem, is 400 milligrams. And how does that come? In 250 milliliters. And then we're going to do the math. This divided by that times that. All right, get your calculator. 42 divided by 400 equals, don't look at it because you're not done. And that will throw people, say, that don't look right. How do you know what looks right at this point? Keep going. Times, wrapped in all the love I can muster. So it's going to have to be, she did not say anything about rounding. It's milliliters per hour. And so I'm rounding it to the whole number. That 5 will make that a 3, but that's about all that's going to happen. So it would be 26 milliliters per hour, what you're going to set the pump at. Okay. All right. I know.